Good evening, good afternoon, good morning from wherever you are joining us from today. My name is Sarah and I'm the Program and Event Manager at the Reactor in Sydney. Welcome to another Microsoft Sydney live stream event. I'd like to welcome this evening Brad McCoy and Roman Shariy. So first of all, we will be starting off with Brad, and Brad is currently the Head of Platform Engineering at Search 365. He comes from a software engineering background and transitioned into DevOps when he's gone through a journey with Kubernetes and Cloud Native. Roman, who will be joining us later, is also an ex-Microsoft employee and currently enjoying working with Azure every day as a DevSecOps Engineer at Methodic. Today, we will be taking a deep dive into building and deploying hybrid and edge computing applications on Azure Kubernetes Service, AKS, on Azure Stack. This session will be approximately 60 minutes with about 10 to 15 minutes at the end for questions. So please do send them through in the Q&A section and we'll try and answer as many as possible. We'll also be uploading this to YouTube for an on-demand version to the Microsoft Reactor YouTube channel. So if you'd like to reference it, it'll be up within the next 24 to 48 hours, and we'll also provide the link to our YouTube channel. But for now, I'd like to hand the floor over to Brad. So Brad, over to you to begin.
Thanks, Sarah, and thanks for organising this event. So as Sarah mentioned, we'll be doing deploying hybrid and edge computing apps with Kubernetes on Azure Stack. So the expected outcomes of today will, by the end of it, you'll be able to understand what Azure Stack is, and we'll go over some use cases for using it and talk a little bit about the Azure Stack family. So we have Stack HCI, Stack Hub, and Stack Edge. Most of this talk will be on Stackage because that's what we've had we had a hackathon recently, Roman and I, and we used the Stackage. So we'll talk mostly about the Edge when we go into the Kubernetes part of it. And then we'll sort of see how Kubernetes fits in with the Stack as well, and how you can deploy a modern app onto the Stack. So the agenda, we'll talk 10 minutes about the Stack family, and 10 minutes over use cases, and then we'll get a little bit deeper talking about Azure architecture, how you can fit a hybrid model using Azure Stack public cloud, or if you want to go fully isolated environment as well. And then at the end of it, we'll have 15 minutes for a Q&A session. If you have any questions throughout, please just chuck them in the Q&A section and we'll answer them. If we don't have time to answer them, we'll get back to you as well. So as Sarah mentioned before, it'll be Roman and myself doing the presentation today. So Roman and I work together at the cloud engineering team for Temenos. I worked there for 3 years and he was there for a year. I'm now working at Search 365 and from Methodic. Yeah, special thanks for Sarah and team at Reactor Sydney for putting this event together, and also my company Search 365 who gave us the opportunity to start building some stuff with Stackage, which was great. So Azure Stack, what is it? So Azure Stack is a portfolio of products that extend Azure services and capabilities to your environment of your choice, from the data center to edge locations and remote offices. Build and deploy hybrid and edge computing applications and run them consistently across location boundaries. So you'll see that there's the three offerings in that picture. So you have Azure Stack HCI, and then you have Hub, and then you have the Stack Edge. So they're all quite similar, but we'll go over why they're different and some use cases of which one might suit you if you're thinking about getting into this hybrid type model. And really, to me, what Stack is it's innovation. So if you still have your applications on premise and you can't quite move to public cloud yet, this really, it gives you the opportunity when new innovation comes with Azure, you have access to that and take them straight away, and you can consistently have your developers build the same way as they will in the cloud on-prem. So you're keeping them up to date as well. So as I just said before, this is the Stack family. We have the Azure Stack HCI, which is scalable virtualization storage for remote branch offices, and it's for high performance workloads. We have Stackage. So within Stackage, there's a few offerings as well. So we'll go over this to Stackage Pro, Stackage Mini, and just Stackage. And that's really optimized for machine learning at the edge. So a lot of use cases where maybe internet's not that good, you can have the edge running, collecting data, processing it on the way when you're going back to upload all the data. And then we have Azure Stack Hub, which is a cloud native integrated system that works in disconnected scenarios. It's good for data sovereignty is everything these days, and quite a restrictor for going to the cloud as well. So this could be a good fit there. And then it's also good for application modernization, like I said before. So for the Stack Edge, run edge computing workloads, we get rapid insights with the Azure managed appliance using compute and hardware accelerated machine learning and edge locations. So if you're familiar with the IoT in Azure and the AI workloads, this is great for you. We'll go over some use cases to talk about that more. And we have the HCI. I'll also show you some of the hardware that you can get for it as well. It's good for modernizing on-prem architecture. And yeah, it's pretty much a duplicate slide from before. So this is the Azure Stack Hub. So you don't actually need connectivity to this. You can run it anywhere you want. You don't have to be connected to Azure. So on this, you can build cloud-native modern apps. You can run Azure consistent IaaS and PaaS services. It's good with compliance with data sovereignty laws and regulations. So there's a lot of, let's say you're in government or maybe finance. It's good for keeping your data on-prem, away from the world, and that will tick the boxes. And then you can either run connected or disconnected from the public cloud. Azure Stack HCI, so this is hyper-converged infrastructure solution. This is good for consolidating data center servers and storage, deploy and manage high-performance scalable SQL servers. So with this one, you can have like a high available solution and active, and you can do some really cool stuff with it. And you can connect to Azure virtually bottomless storage, so you can utilize all the good storage solutions in Azure and provide compute and storage at remote branch offices. So that's quite cool. If some of your offices aren't in good internet, they're more remote, it's a good option. And then the last one of the family is Stackage. So these small boxes are quite powerful. They're optimized for machine learning. You can transfer the data from the edge to the cloud. And you can also you don't have to connect to the cloud if you don't want to. So I had this stack box in my house when I was developing on it, and I pretty much didn't connect to the internet. And then you can extend the compute, the AI, and storage to each environments. And this one, you don't have to pay upfront costs for hardware because you can pay as a monthly subscription. And just going back to we mentioned the hyper-converged solution. If that's unfamiliar to some people, I just have the definition here. So that's what HCI stands for when we say Stack HCI. So it's hyper-converged infrastructure. It's a software-defined IT infrastructure that virtualizes all the elements of the conventional hardware-defined system. So these are pretty small, but you can see this is the solutions that you can buy. So yeah, pretty big machines. They integrate with a lot of different brands, and you can, if you want to go to check this out, you can check it out on the Microsoft Docs and see what one fits you if you want to use it. And you can also, there's a development kit as well, which I'll briefly talk about, where if you do want to test this out, you can either use the kit on your own hardware, or you can spin up a VM in the cloud and then test out, if Stack's right for you, or even if you want to do a bit of dev and see how the deployments work, etc. So Azure Stack HCI is a hyper-converged cluster that uses validated hardware to run visualized Windows and Linux workloads on-premise and easy to connect to Azure cloud-based backup, recovery, and monitoring. So it was initially based on Windows Server 2019, and now it's delivered with service with subscription-based licensing model and hybrid capabilities built in. So yeah, and then some example use cases for Azure Stack HCI for remote or branch office systems, data center consolidation, virtual desktop infrastructure, business critical infrastructure. So maybe you can think about, let's say we have a fintech company that wants to trade shares and they have algorithms that buy shares at a certain time, and every second counts. So I can see where this would add value if a lot of those, they want to stay on-prem. So if you do want to leverage that innovation, you could think about having Stack on-prem instead of your on-prem infrastructure and worry more about the trading than trying to reinvent the wheel. And lower cost storage, high availability and disaster recovery in the cloud, virtualizing enterprise apps like SQL Server. So AKS on Azure Stack. This is quite cool. So it takes our popular AKS and it makes it available to customers to run on-prem. So delivering Azure consistency, a familiar Azure experience, ease of use, and high security for containerized applications. AKS on Stack HCI enables developers and administrators to deploy and manage containerized apps. This is one really thing I like about it. So you go into the portal, which I'll show you soon, and then you essentially deploy the AKS to Stack, and then you can start deploying your applications like you do on the cloud. So you don't need half a team of developers for on-prem and half for the cloud. You can consolidate and move forward as one team and write consistent code that will go over both. And this is the development kit I was talking about. They call it ASDK. So yeah, they have pretty big requirements that you need for this. So it says minimum is, so disk drives, that doesn't really matter, but what does matter is 16 physical core CPU and 192 gig of RAM. So when I first got into Stack, I was thinking, okay, how can I start development and do a bit of a proof of concept on it? And I looked at this and thought, well, I don't have that sort of stuff at my house. And then I looked at the cost of the VM in the cloud to spin that up, and then I figured that the Edge device is around the same amount of money, so I might as well just get the real deal. So instead of using this, we ended up using the Edge, the Stackage, which we'll talk about later. And now we'll go to Stack Hub. So Azure Stack Hub is an extension of Azure. It brings the agility and innovation of cloud computing to your on-premise environment, enabling only a hybrid cloud that allows you to build and deploy hybrid apps anywhere. Some use cases of this is financial modeling, clinical and claims data, IoT, device analytics, retail assortment optimization, supply chain optimization, industrial IoT, predictive maintenance, smart city, and citizen engagement. And this is the HCI where you can deploy your Kubernetes cluster. So you just go into the admin center and then you can add it. And now we'll talk a little bit about Stack Hub. So this is what the portal looks like. So it's quite similar to the look and feel of the public cloud. And then, you can see you have all your Azure services as well. So, load balancers, storage accounts, VNets, monitor. And if you want to check out some of the projects that they're actually using on Stack, you can go to AI for Good. This is quite an interesting site where Microsoft give grants to people to, fix some of the big problems in the world, like hunger, terrorism, things like that. And you can sort of get a sense of how they use the AI. So this is a use case now. So Azure Hub. So the context and the problem, contested stores would like to gain insights on how customers are receiving their current products in relation to store layout. They're unable to place staff in every section, and that's inefficient to have the team of analysts review the entire store's camera footage. In addition, none of the stores have enough bandwidth to stream the video of the cameras in the cloud. So let's see the solution here. So you can see they have the AI Dev Kit, and we have Azure at the top, and then Azure Stack Hub at the bottom. So Azure Stack Hub, the data will go into the blob storage. They will then have an Azure function that will then process some of that data, and then once they transform it, they can then push it to the Event Hub when they have the internet, and then they can then go report on that in Power BI. So you can also leverage cognitive services in Kubernetes as well, which is really cool, something I'd like to look into. So you can run that in a container and then run that on-prem as well if you don't have access to the cloud. So yeah, that just talks about pretty much what I talked about then, about some of the use cases. So Azure Stack Edge. So let's see if we have, so physical retail stores lose sales because when customers look at an item, it's not present on the shelf. So however, the item could have been in the back of the store and it has been restocked. So stores would like to use them staff more efficiently and get automatically notified when items need restocking. So the solution example uses an edge device, like in Azure Stack Edge in each store, which efficiently processes data from cameras in the store. This optimized design that stores relevant to the cloud. The design saves bandwidth, storage space, and ensures customer privacy. As frames are read from each camera, the ML model processes the image and returns any out of stock areas. The image and out of stock areas are displayed on the local web app, and this data can be sent to Power BI. So yeah, what's good about the Mini R? The case is quite strong, so it's designed for a pretty tough environment. So think of like a military vehicle going around with it. It's not waterproof, so it's not real harsh conditions, but it's pretty solid. And then you can operate either disconnected or connected, so you can even have a car battery where you can hook it up to, and then yeah, you can benefit from that hardware accelerated machine learning and then transfer data over the network. So here there's another use case of this is using Stack Edge. So here you can see that they're using the IoT for deployments, and then the file share at the bottom is a very big hard drive, and then essentially those are contained there that are microservices that are processing events from the camera. So that would be using that use case where they need to find out whether to restock the shelf or not, and then they would get an alert. So how that solution works, images are captured over the network camera, and then the image is resized and sent to the interface driver, which communicates the ML model to determine if they have out-of-stock images. The ML model returns any out-of-stock images, and see back there. So we've got the capture module, the driver, and then the driver uploads the raw image to blob. So that's actually going into the cloud if you want connected. And then the bounding box processor adds bounding boxes to the image, caches the image path in the image database, which is the relatively low. And then messages from the IoT are aggregated in the time series. So yeah, it helps challenges. Pretty much we just talked about that then. They also didn't talk about compliance, and then easy for the network data transfer, easily quickly transfer data to Azure for further computing and archive purposes. So Roman, are you online to go through some of the architecture?
So unfortunately, we haven't been able to get Roman on. We're having some technical difficulties.
That's fine.
Yeah, so if you can proceed for now, and we'll see if we can get him on little bit.
Yeah, no worries. So here you can see we have the Stackage. So that box over there on the left that's the Stackage, and then that's connected to the cloud. So you can see that on Stackage you can run VMs, Kubernetes. You can leverage the local storage as well. So this here, if you think about how my product is using it, we're using Kubernetes and VM as well, and we're making use, which we'll show you later on in the Kubernetes part, where we can use the local storage as well. And then if you want, you can hook up your cluster to the Azure storage as well as a NFS server. So you can really leverage the cloud if you want to. And then you can also see on the right where you can deploy from IoT Hub. So if you want to run a stateless application without storage, you can deploy from IoT Hub, and then you go into the portal, you specify your container image, and then that will deploy it and do all the deployment for you. Or if you want, you can use Azure Arc, which has just been released for Kubernetes and Stack about a couple of months ago, I believe. And if you're like me, I use Helm to do my deployment. So I just hook my cluster up to my computer and I deploy through Helm, because generally each stack environment's a little bit different. So I find it easy. And we'll go over a little bit of DevOps stuff that you can do as well if you want to. So here you can see the diagram. So you can see it's using Azure DevOps. You can either choose if you want the build agent on your on-premise or in the cloud. It doesn't really matter. You can have your ACI repositories as well. So we also have a use case at the moment for a client where we can't store anything at all on Azure Public. So we're going to have to make like container repositories inside the stack, which is going to be quite interesting because it's an ESL environment. So you can only, it has a long process where you have to go through security scanning. You have to take it from one USB to the other. It's got to be approved. So that's what we actually won't use this sort of model. It's going to be fully stack, but you can see how you can use hybrid as well. And then you can leverage the traffic manager or front door to then connect to the cluster. If you have, you can maybe have two regions, or one going to public, one going to stack. You can have like a failover. You can do some pretty cool stuff. So that is pretty traditional Kubernetes setup. You have your ingress, your front-end namespace, your back-end, and then utility service as well. So we use Prometheus, Grafana, Nginx, Ingress, MySQL. You can have external data stores as well. So they can run on, under the covers, they run on VMs, which you can deploy. And then you don't have to run the AKE engine or the AKS engine. You can run other engines as well. You could also, if you really wanted to, you could spin up VMs and then run your Kubernetes cluster from scratch. So this is the Azure Stack Edge, just to put into consideration how big it is. So you can see it's pretty small, and also you can run it at edge without a power cord as well. My wife got annoyed with this because when you turn it on, it sounds like a jet plane. And this is the process when you actually go into the portal and buy one. So yeah, to get started, you select your subscription, and then you select your country. I think we're one of the first ones in Australia to get it sent to, so ours had to come from Pittsburgh. It takes about 2 weeks to come, probably, after setting up and everything. And then here you can see some of the different edge sizes and prices. So we use the Azure Stack Mini R, so that's around 2,000 Australian per month, and that's connected to your subscription. So the billing will start as soon as they ship it, about 15 days after they ship it. So. And then, yeah, we got the ultra portable Wi-Fi enabled one, which is quite cool. And then you can get other different HCIs, as you know, we showed before, and then the hub. And then once it arrives, you go into the portal, you need to generate your activation key, and then that will automatically get sent to Key Vault. That will be saved there. And then you go into the stack, and then you can activate your device. And then you can see, so some of it you manage from the portal. So the initial setup, if you want to do VMs as well, you can create them there. For the edge, you have to enable IoT Edge to build your Kubernetes cluster, so that does it all for you. So we didn't figure that out for a while, and then we found out that you actually have to install that first, and then your Kubernetes cluster will come out. And then also, which we'll show soon, it comes up with a Kubernetes dashboard as well, so you can see how it all works. And then the cloud storage gateway as well. So we'll talk about that also. So this is, yeah, the device activation key. Just copy and paste that, and then you can put it into the stack. So when we first got it, we didn't know what the IP was, so we ended up having to go into my router. So we connected the Ethernet cable into my router, then it came up over here saying 192.168.0.13, and then that's how we figured out how to sign into the stack. So we entered that address then, and then it came up like this. So then you can sign to the device. That's a little bit more about IoT Edge as well. So I talked before about deploying containers, so you can set that up as a module as well if you want to go down the IoT Edge way. So you sign into your device. That'll run all the diagnostic tests. That takes 10 minutes, I think, too long, maybe minutes. And then once you're in, you need to configure your network. You can do your device setup, security certificates as well. We made the mistake of changing the name of the device, and then it sort of made things harder. So we ended up doing a reset, and then just leaving the name. It was going to be more trouble than what it was worth. And then, yeah, obviously activate it as well. This is what the device looks like. So you can see you have your Kubernetes API endpoints that at that time we didn't create it. That's when we need to do the IoT enablement. And then you can see some of the other endpoints as well. Yeah, we updated the server as well. So you can see on the left there of the Azure panel, same look and feel as the Azure portal. So you can, the main one is your network and compute. So you have to configure them properly. You can do web proxy, set up the time zone, certificates, VPN, and then just a few sort of normal devices. And this one, what we had to work out as well. So I was using my home router, so we had to change port 2 to be able to go through my gateway. And then we were able to sort out all the, so then we clicked on the port 2 hyperlink, and then that would come up. So that's the network. And then for compute, we came here to enable Kubernetes. So I clicked on that, and then you'll see for port 2, you can put your range in Kubernetes. So we've got the .14 and then as well. And then you can see the external service. So when I go to 192.168.0.20, that was how I do my ingress into Kubernetes. So all my traffic would go through that IP there. And you can change that based on your environment. I just have it to because it's running at home. So Kubernetes networking. So how does that work on Stackage Pro? They use Calico, they use MetaLV and Core DNS. They're the components that install networking on the edge device. Calico assigns the IP addresses from the private IP range to every pod. It configures the network for these pods, so that pod on node can communicate with the pod to another node. The MirrorLB runs an in-cluster pod and assign architecture to the services on type load balance there. The load balance architectures are chosen from the service IP range provided via the local UI. And then they also run core DNS as well, so this allows the DNS record to map the service name to the cluster IP address. So when I came in, I sort of had to play around. I can see this as well. So it also comes with the Kubernetes Dashboard. You can go into the 0.15 and then you generate your token from the portal, so that lasts around 5 or 10 minutes. And then you can see, yeah, this is quite cool for sort of exploring how the Kubernetes is set up on this particular environment. You can see, the CPU, and it was quite good, especially for engineers in the company that haven't really played with Kubernetes. This is a good place to sort of come and see how each of the objects work. And then you can see things like deployments. That was the IoT Edge deployment that is on by default. So that is the default. And then, like I spoke briefly about before, ways you can put the applications onto the cluster using kubectl or Helm. You can use IoT Edge in the portal as well, that does it for you if you can do it. So there's 2 modes, or probably 3, but one mode is for being disconnected and the other connected as well. So you can choose if you want to connect to the cloud or not. And then Kubernetes can also be integrated with the IoT Edge workloads on Azure Stack Pro device, where Kubernetes provides scale and ecosystem, and IoT provides the IoT-centric ecosystem. So the Kubernetes layer is used for the infrastructure layer to deploy the IoT Edge workloads, and the module lifetime and network load balance is managed by Kubernetes, whereas the Edge application platform is managed by the IoT Edge. So similar to what I was talking about before, so IoT can handle all of the application deployments as well to Kubernetes that will be taken care of, which is quite good. Kubernetes and Azure Arc. So Azure Arc is a hybrid management tool that will allow you to deploy applications on your Kubernetes cluster. So Azure Arc also allows you to use Azure Monitor for containers to view onto the clusters. So beginning March 2021, which was this month, Azure Arc was enabled Kubernetes, so it will be generally available to users probably now. And then for the preview customer, Azure Arc enabled will be available at no extra charge. So Azure Arc will be something we're looking at probably next. So probably next month or start to see how that can work with our Stack applications. And this is what the namespaces look like. So when I got the cluster, I probably should have read the documentation, but I started having a look around as developers do, and then I started seeing, the namespaces set up for you as IoT Edge, DB namespace, so that will take care of backups, etc. I added a few as well, so our product's called Overwatch, so that has the API backend UI, and then I also added the engine service as well. So yeah, Kubernetes pods are stateless, but applications that are generally these days can be stateful as well. So because pods can be short-lived, they restart, failover, etc. Requirements and storage associated with the pod. So to be able to run these stateful, the storage must live outside the pod, be independent of the pod lifecycle, and be accessible from all the Kubernetes nodes. So in this case, there's just 2 nodes on the Stackage. On the HCI hub has more, and I'll talk a little bit about a diagram about them soon. And then the Stackage also has a built-in storage class called the AWS Node Local, so that uses a data storage attached to the node. The storage class supports dynamic provision, so you can make a storage class reference in the pod applications, and it's automatically created for you. So I haven't actually used that yet. But like I said, when I first started, I didn't really look at the documentation, and I came in and see how I looked for pretty much any persistent volume and seeing how that was configured. And I seen that they're actually using something called flex volume. So I did a bit of research seeing what a flex volume was, and essentially it's a custom. So yeah, I'll just read the out of tree volume plugins, the out of tree volume plugin container storage interface and flex volume. These enable plugins enable storage vendors to create custom storage plugins without adding their own source code to the Kubernetes repository. So it's like a marketplace for storage for Kubernetes. And this is what it was configured as. I've tried that worked for my other PV as well. So then I can put a persistent volume claim onto that also. So storage provisioning, you can also statically provision persistent volumes that are created using the device storage capabilities. With provision share with the edge compute option is enabled, this action creates a PV resource automatically in its cluster. So you can come into the portal there, see the cloud storage gateways, have the option of SMB NFS, and then choose if you want to share it with the edge computer. This is quite good as well. And then I was talking briefly about the nodes before. So you have on here we have the master node and the worker node. And yeah, the storage of the hardware is it's in the bottom. So yeah, that's for the edge. It just runs to a standard with 2 nodes for Stack HCI, and yeah, it's more doing more things with it. And then yeah, as talked about before, it's running Calico, Core DNS, and a couple other plugins as well. And then they have the metric server on there by default. They also do some backups in the DB namespace, so do some snapshots of the etcd. Yeah, so that's how they do the backups there. And now we'll go on to the Q&A session. If anyone has any questions, please let us know. Otherwise, you can reach out to me as well, and I'm happy to answer any questions that anyone might have.
Thanks, Brad. We actually haven't had any questions come through in the Q&A just yet, but if people have them, please start sending them through. If you have any links you want to share, Brad, for instance, if people have follow-up questions, did you want to put that, like your email address or a way to contact you into the Q&A section?
Yeah, so you can see the link at the bottom. That's the community group that's running this now. So that's the community.cncf.io/manly. So you can come and join that group if you want, and then you can chat to us on there. We're on the CNCF Slack as well, so you can add yourself to that for free. You can sign up if you want to see some more. We go through quite a lot of Kubernetes training, like CKD, and we do a lot of talks, mostly on open source and Kubernetes. So you can reach out to us on that.
Awesome. So we'll just give people a minute to write that one down. And also in the meantime, what I'm going to do, as I mentioned at the beginning, I'm going to put in the Q&A section a link to our survey. If you have time to just fill out that survey before you head off for the rest of your day, that'll help us curate our topics for the future. So it would really help us. I'm just going to put that one in there now, and also just a link to our meetup page for any upcoming events with the Sydney Reactor, and our YouTube channel, which I mentioned. This video will be uploaded for an on-demand version in the next 24 to 48 hours. So if there's anything that you missed from the presentation today or would like to refer back to, you can do so on our YouTube channel in the coming days. Haven't had any questions coming through, so it means, Brad, you've obviously answered all questions. Apologies we couldn't have Roman come on. We were having some technical issues in the background. But you, as Brad's showing you there, you can join that community and get some more information after this presentation. I'd like to thank Brad and Roman in spirit for joining us, and everyone that joined us online today. Wherever you are, have a good rest of your morning, your afternoon, your evening, and we hope to see you again for another Microsoft Reactor live stream event. Brad, is there anything you'd like to close with?
Yeah, just hopefully you got something out of today. I know that Stack's a big topic, but hopefully it at least gave you sort of a high-level overview of what you can do. And if anyone has any more specific questions, I'm happy to maybe run another session on that if that's what you want. And thank you, Sarah.
Not a problem. We just had Ben say last minute, very informative, and thank you, Brad. So thank you, Ben, for your comment. And thank you again, Brad. And we'll see everyone next time, and hopefully we can have you back again for part 2 with Roman.
All right. Thank you very much, everyone.
All right. Have a good evening, everyone.
Cheers.